All right, in this lesson, we're going to take a look at using limits to find tangents. So if we take a look back at lesson 1.1 in our discussion on the tangent problem, we were trying to find an equation of a tangent line to a given curve through a certain point. The problem was that we only had coordinates of one point on the tangent line, so we couldn't calculate the slope of the tangent line because we wound up with that 0 over 0. So instead, we calculate the limit of the slopes of the secant lines on either side of the point that we're given. Now we can see a visual representation of this here. We have any point on the curve has the coordinates of x and f of x. If I take an x value and I sub it into the function, I can solve what the y value or the f of x value is. To calculate the slope of the tangent at the point of a and f of a, we need to select another point, which we're going to call q, to find the slope of the secant line. So we have the point of tangency, which we call a and f of a, which we can say, well, that's just the same as x1 and y1, the point we're trying to get to. And then we take any other point, x and f of x, and we can call that x2 and y2. So when we think of our slope formula, where we had the y2 minus y1 over x2 minus x1, then we're just replacing y2 and y1 and x2 and x1 with f of x, f of a, and a, but we're still calculating what that change in y and the change in x are. And this is finding the slope of the secant, like we see here. If we're using limits, we can say that the tangent line is the limit position of the sequence of secant lines where I have q1, q2, q3, q4, q5, q6, until we get towards the actual point of P. The slope of the secant PQ gets closer and closer to the slope of the tangent line. Now, it's important to note that this formula is not on the formula sheet. We can see here on our graph that the point P is going to be the A and F of A, or the point of tangency. And we also need to remember that at that point of tangency, x is equal to a. So if we put this into our first example, and it says determine the slope and the equation of the tangent line to the curve y is equal to 2x squared plus 4x minus 1, then this is our f of x. It's asking for this at the point 2 and 5, which is, as we already know, our point of tangency, which represents a and f of a, or in this case, a is equal to 2 and f of a is equal to 15. Now, when we're solving the slope of this, we're going to use that slope formula that's not on your formula sheet we gave on the previous page. The slope is going to be the limit as x gets closer and closer to the point of tangency, or a, where f of x minus f of a divided by x minus a. And at this point, we know we have a and we have f of a, so we can sub that into our formula. We know that we have the representation for f of x up here, so we can sub that into our formula. And what we get when we do those substitutions is the slope is equal to the limit as x approaches 2 of f of x is 2x squared plus 4x minus 1 minus f of a, which is just 15. This is all divided by x minus a, which is 2. And at this point, I'm just going to simplify this function. So we're going to say that when we combine them, the limit as x approaches 2 of 2x squared plus 4x, and negative 1 and negative 15 make negative 16, over x minus 2 is going to equal the limit as x approaches 2 of 2, and when I factor this down, if I have 2 and x squared plus 2x minus 8, then I can factor it for one more step in here and call that x plus 4 and x minus 2. And I can see I have a common factor in the numerator and denominator that I'm going to eliminate. And my slope is the limit as x approaches 2 of 2 and x plus 4, which means the limit, now that I can do direct substitution, is 2 times 2 plus 4, which is 12. Remembering that this is the representation of the slope at the point of tangency. The second part of the question asked us to put this into general form. So for part 2, for the equation, I'm going to use that slope point form like we frequently do. Y minus y2 is equal to m bracket x minus x2. And we know that y2 and x2, or y1 and x1, however you wrote it in your formula, is going to be the point of tangency 15 and 2. The slope we just solved, we have a slope of 12. And then y minus 15 is equal to 12x minus 24. Because my x value is positive, I'm going to move everything to the right, so I'm going to subtract y from both sides to get negative y. I'm going to add 15 to both sides to get negative 9. Therefore, 12x minus y minus 9 is equal to 0 is my general form of the function. Another formula we can use based on the previous one is we're going to change our x minus a and let it be represented as h, which means that the change in x from the denominator is going to be that difference that takes place. That change in x is just h, how much x is changed by. Now, when we substitute that into our equation and we get the second point where we're going to have a plus h and f of a plus h, because remember, we're solving f of that new x value, where I have the point of here's x1, here's x2, and just like in the previous one, my point of tangency did not change. Then we wind up with a new formula where the change in x is just h, and the change in y is that f of a plus h, my y at 0.2, take away my f of a, my y at 0.1. Once again, not on the formula sheet. But we're going to use it so much that you're going to memorize it in no time.